Exactly. The air's thin, the sky's just dark, and far overhead you see this pale blue marble hanging in the blackness. That's Earth.
And that vision, it isn't just a dream or some metaphor anymore. It's become the active engineering challenge of our century.
It really has. We proved half a century ago that we can explore space. The moon landing sort of closed that chapter. But the real question, the one driving this deep dive, is why now? Why, after decades of, let's be honest, relative stagnation, are we rushing back into space?
What's pushing us?
Yeah, what are the economic, the geopolitical, even the survival drivers pushing us beyond the horizon? And what does, say, the next 30 years really look like?
Our mission today is to get past the headlines and really guide you through the implications. We're not just talking about rockets here. We're looking at a fundamental shift in how humanity sees itself as we start to become a multi-planetary species.
And that requires balancing the really exciting promise of it all with some extremely harsh realities. So let's start with that historical paradox. Apollo was, you could argue, humanity's greatest technological achievement. We went to the moon, we proved it could be done, and then almost immediately, public interest just vanished. Budgets faded. Why?
Well, it was a classic case of the goal being defined by a conflict, right? The Cold War.
Yeah.
Once the U.S. won that symbolic race to the moon, the intense ideological pressure was gone. The economic cost, which was, enormous, over 4% of the entire U.S. federal budget at its peak, it just wasn't sustainable without that motivator.
So space exploration basically hit the pause button.
It did. But if you fast forward to the last, say, 10 to 15 years, the entire landscape has been rebooted.
And the trigger this time isn't a new Cold War. It's a massive technological and economic shift. We talk about the cost of access dropping, but let's actually put some numbers on that.
We should, because the difference is staggering. During the shuttle era, to get 1 single kilogram of anything into low Earth orbit...
Just 1 kilogram, like a bag of sugar.
Exactly. It costs around $10,000 in adjusted currency. That price point kept space solely in the hands of governments.
No one else could afford it.
But then came reusable launch systems, championed by the private sector. And that fundamentally changed the equation.
The rockets that land themselves, that's the key innovation.
That's the one. So what's the price point now? While it fluctuates, the goal for some of these heavy lift vehicles has dropped to possibly less than $3,000 per kilogram.
Wow. From 10,000 to 3,000.
It's a game changer. And that cost reduction is what fueled the second huge shift, the rise of these independent, really aggressive private companies, SpaceX, Blue Origin. Now, governments are often the customers, not the sole providers.
But our sources suggest there's something deeper going on beyond the balance sheets, an almost philosophical motive driving this push outward. It's this feeling that Earth itself is fundamentally fragile.
Yes, and what's fascinating is how the material connects specific pressures here on Earth directly to the desire for, off-world redundancy.
A backup plan.
A backup plan. They detail the increasing severity of climate crises, the shock of global pandemics, the low-level but constant threat of asteroid impacts, and just general geopolitical instability.
It's the ultimate don't put all your eggs in one basket argument.
Precisely. And when you take all that together, it forces humanity to confront a really fundamental question. Should Earth be our only home? The move outward is shifting from pure exploration into a form of long-term species insurance.
So we really need to get rid of this idea that the space race ended in 1969. It didn't end. It just evolved into something far more complex.
And way more competitive. The old race was binary. It was the USA versus the Soviet Union, flags and ideology.
Right.
The new structure is multi-layered. It's still nations versus nations for sure, but you also see companies versus governments, and sometimes you see different billionaires and their companies competing fiercely with each other.
And you see these national ambitions everywhere. I mean, the United States, with the Artemis program, is actively trying to create a sustainable, permanent human presence on the moon.
And Artemis is incredibly complex. It's not just a quick visit. It involves the huge Space Launch System rocket. It has goals to land the first woman and first person of color on the moon. And crucially, it's about building permanent infrastructure, like the Gateway space station in lunar orbit.
And China is right there with them. Their long-term vision includes a moon research station, maybe by the early 2030s.
And their success with the Tiangong space station and getting lunar samples back, it proves they have the capacity and the strategic patience to pull it off.
Meanwhile, you have countries like India, with their incredibly cost-effective missions, proving that you don't need the GDP of a superpower to do this anymore.
That democratization of access is a huge part of this new race. But the real disruptor here is the private entity, like SpaceX.
They're not just launching satellites, they're launching American astronauts, resupplying space stations, and very openly planning to send people to Mars, often at a speed governments just can't match.
And this gets to the heart of the control question. Is that speed, that efficiency, worth the trade-off? Should space development be led by governments who, traditionally fund pure research and try to ensure global access?
Or by corporations who are driven by profit and return on investment.
Exactly. You're balancing altruism against acceleration. Private speed gets us there faster, but it brings up all these questions about equity and ownership.
So when you connect all those dots, the implication is pretty stark. Whoever controls the infrastructure of space, the lunar landers, the communication hubs, the refueling stations in orbit, they control the future.
Absolutely. This new space race is fundamentally a scramble for control, for access, and for economic dominance. It's about way more than just scientific firsts.
Which brings us to Mars, the ultimate goal, the symbol of this whole multi-planetary future. But the second you move past the beautiful concept art, you run head first into the brutal reality of living there.
The environmental challenges are just overwhelming. I mean, we are talking about surviving on a planet with less than 1% of Earth's atmospheric pressure.
Which means instant death without a soup.
Instant death. You're facing brutal solar and cosmic radiation because there's no magnetosphere to protect you.
Yeah.
And the cold temperatures regularly plunge to minus 100 degrees Celsius.
And the isolation. That, to me, is the most terrifying factor. If something breaks, if someone gets sick, help is months, maybe even years away. So why Mars? With all that, why is it still the target?
Because despite all those dangers, Mars is the closest planetary body that could someday, and I have to stress someday, support human life using its own resources. It has frozen water ice, it has the elements needed for rocket fuel and for life support.
So what does daily life actually look like for those first crews? It's not glamorous exploration, is it?
Not at all. We're talking about living for years in tiny, confined, pressurized habitats, probably buried underground for radiation shielding. They'll rely on closed-loop life support, which means meticulously recycling every single drop of water, every breath of air. The food will be artificial, grown in hydroponic bays, maybe some nutrient pastes.
I read about the psychological studies, the analog missions they do here on Earth where crews live in isolation for months.
The HERA missions, yes, and they show that mental endurance is just as critical as any technical skill. The psychological load of knowing you cannot just step outside, the friction in a small crew, and the fact that for the first pioneers, there's effectively no return ticket for years. That defines the experience.
So it changes who we send. We think of them as these heroic explorers, but the sources suggest a different profile. The first people on Mars won't be explorers. They'll be disciplined, highly trained survivors, and maintenance technicians.
That is the essential takeaway. Space colonization is ultimately about endurance, not adventure. It's about a deep, sustained commitment to monotonous, difficult work under impossible pressure.
And those challenges force us to think about the bigger picture, which leads right into the messy legal questions. Let's shift from survival to law. Who owns the moon? Who owns Mars?
Right now, the legal framework is extremely weak. It rests on the 1967 Outer Space Treaty, which basically says celestial bodies belong to all humankind and no nation can claim them.
So no one owns them.
In theory. But the sources all highlight that this treaty, written long before commercial space travel was a thing, is already pretty much obsolete.
Obsolete because of the potential for a gold rush. I mean, if a private company mines an asteroid with trillions of dollars worth of rare metals, that legal vacuum is going to shatter instantly. Who profits? The company, the country it launched from, everyone.
Well, exactly. And same for the moon. If a corporate group builds the first permanent base on the South Pole where the water ice is, do they get to control access to that water? These are questions we need to answer before the first trillion-dollar resource is pulled out of the ground.
Which brings us to the hardest question of all, the philosophical one. Are we doing all this as genuine progress? Or are we just trying to escape the problems we've made for ourselves down here on Earth?
The sources present really balanced views on this, and it's important to be impartial. The pro-space argument is that exploration inherently inspires us. It drives innovation in tech, materials, energy, things that have huge benefits back on Earth. Think of it as a giant R&D project for humanity.
And the counterargument.
The counterargument is that it's a massive, expensive distraction. It diverts brilliant minds, financial capital, and political attention away from immediate crises like climate change, poverty, failing infrastructure.
That we should fix our home before building a new one.
That's the core of it. And the truth, as the analysis suggests, is probably somewhere in the middle. It can be a massive inspiration and, if we're not careful, a dangerous distraction. It's all about managing that balance.
Let's pull back from those huge questions for a second. Just focus on the present.
Yeah.
Because space exploration isn't some distant dream. It's already woven into our modern lives right now.
Absolutely. It's easy to forget how much of our daily life relies on space infrastructure. It's not out there, it's in your pocket, it's in your car.
GPS is the obvious one. Satellite internet.
And weather forecasting. Advanced satellites save countless lives every year by improving storm tracking and disaster prediction. And the tech transfer goes even deeper. Think about medical advances from keeping astronauts healthy.
Oh, like telemedicine.
Exactly. Remote surgical tools, advanced diagnostics. They were developed for crews millions of miles from a doctor, and now they're being used in remote clinics on Earth. Even things like water purification methods were perfected for space.
So that's the tangible benefit. But then there's the purely scientific return, which just reshapes our whole worldview.
Every new telescope, from Hubble to the Webb, just pushes the boundaries of what we know. We are discovering new galaxies, finding potentially habitable planets around other stars, and getting closer to understanding the origins of the universe itself.
It's the ultimate perspective shift.
It is. Every single one of those images from deep space, every piece of data from a probe orbiting Jupiter, it delivers the same reminder. We are very, very small, but we are capable of incredible things.
So if we synthesize everything, the cost, the ambition, the technology, the harsh reality, what's a truly realistic timeline for this future? What can people expect to see in their lifetimes?
The sources give a pretty grounded breakdown. Realistically, in the next 20 years, we should expect to see sustained, semi-permanent moon bases. International, corporate-led, something like that. We'll also see regular commercial space travel really scale up.
So the moon becomes the next major staging post, kind of like Antarctica is for research today.
That's a perfect analogy. Then if you look further out, maybe 30 to 50 years, that's when the goals get truly transformative.
And what does that look like?
That's the window for the first long-term Mars habitats. Crewed, multi-year missions focused on self-sufficiency. We'll also probably see the first real asteroid mining experiments. And, critically, space will shift from being a research zone funded by governments to a true economic zone, where companies are generating revenue and building real infrastructure.
And if that timeline holds, what does it all mean for us back here on Earth?
It means we've successfully diversified the risk for the human species. The final synthesis is clear. Humanity isn't going to leave Earth behind. But through a ton of effort, we might finally, definitively, become multi-planetary.
You know, every great civilization eventually hits a point where it looks outward, beyond its boundaries, for new frontiers. For us, that moment is undeniably now.
And this whole deep dive really shows that this new space era is about deciding our place in the universe. It's about using technology to overcome impossible odds, but also confronting these profound ethical questions about who we are and what we want to become.
The story is shifting from an adventure to an endurance test. So I'll leave you with the ultimate personal choice from the sources, something to think about. If you were offered a one-way ticket to Mars, no fame, no guarantee of survival, just the chance to be part of humanity's next arduous chapter, would you take it?
That really is the question.